On March 27, 1977, the aviation industry suffered the worst aviation disaster known to man. The events leading up to two 747 planes colliding headfirst on a runway are difficult to comprehend. At 1:15 local time, at the Gran Canaria International Airport, a bomb had exploded at one of the terminals. In an apparent terror attack, authorities had no choice but to close the airport and divert all incoming flights to other airports. Two of the five large planes to be diverted to Los Rodeos Airport were Pan American Flight 1736 from New York City and the KLM Flight 4805 flying from Amsterdam to the Gran Canaria. Los Rodeos is a small airport with one major runway, one major taxiway, and several minor taxiways that combine the two together. The airport is not designed to be used by such large airplanes, as a heavy layer of dense fog dropped the visibility to about 750 feet. This caused mayhem for the pilots. Once the terrorist threat was contained, the Pan American flight was ready for departure, but waiting for the KLM flight to finish fueling. With such a dense blanket of clouds covering the runway, air traffic control could not see the planes on the runway. After being grounded for several hours, the captain of the KLM flight 4805 feared if he wasn't able to depart the Gran Canaria soon, then the flight would have to be canceled due to a new company policy preventing pilots from going over their flight time. The consequences for this would be a loss of the pilots' licenses. ATC ordered the captain of the KLM flight to back taxi down the runway, meaning use a portion of the runway to taxi and then wait for them to give clearance. At the same time, ATC ordered the Pan American captain to follow the KLM but pull off of the runway at the third minor taxiway on the left to allow for the KLM flight to take off. The Pan American pilot felt that his plane couldn't make the turn for the third taxiway and tried to go to the fourth. Two simultaneous radio transmissions resulted in neither message being understood. One difficulty with this, the KLM captain, without the proper clearance for takeoff, pushed full throttle. The KLM flight 4805 was barreling full speed down the runway. Meanwhile, the Pan American flight hadn't cleared the runway, but due to limited visibility, the KLM flight struck directly into them. A miscommunication was only exacerbated due to the dense fog. The crash could have been avoided if proper pre-flight planning checklists had been performed. Along with pilot and crew error, loss of positional and situational awareness, peer pressure, and many other operational pitfalls, this tragedy occurred. 583 people were killed. One difficulty with this airport has always been cloud conditions. Tenerife is very different from other airports around the world. Tenerife sits 2,073 feet above sea level, allowing low-level clouds on the ground and surrounding coastal clouds to move in at ground level. In addition to unusual cloud conditions, local high terrain around Tenerife causes a Venturi effect at the airport, so that local conditions of increased wind speed and decreased pressure can result in an increased cloud density. These conditions cause extreme difficulties for pilots trying to take off and land, similar to valley fog. This is a diagram to help illustrate what the airport looked like and some of the photos from the crash. As you can see, the red line illustrates the KLM flight going down the runway, turning around, and the Pan American flight following it. Now you see that tight left turn that had to be taken by the Pan American flight. The pilot did not think that that was the taxiway that his plane could take, and meanwhile in the NTSB report it was admitted that it was too tight for the plane to take. So it went for the fourth, and that was when the miscommunication happened with the simultaneous radio communications. If any of the preconditions or subsequent unsafe acts did not occur, this tragic aircraft mishap would have been avoided. Some of the preconditions caused another, yet some existed independently. The conditions of all these latent and active failures arising on the same day, place, and time provides a critical illustration as to how, when the holes in the Swiss cheese model align, an accident may be inevitable. Examples of those holes are the explosion at the Gran Canaria, the size of the Tenerife airport, the dense fog, the absence of ground radar, KLM being fully refueled, Pan American 1736, missing the correct turn, and then the personality traits of the captain and first officer. The captain was highly criticized for how emphatically he was blamed on the cockpit voice recording conversations were released. Upon first glance, it seemed that the captain's eagerness to depart led him to twice increase input throttles with the intention to take off prior to the ATC giving clearance. I'd like to introduce Chris Fuller, captain of an A320, retired Air Force air traffic controller. I know that the aviation industry, unfortunately, is one where we learn from our mistakes, and mistakes have to be made. But what exactly from Tenerife, what in the aviation safety concepts have we adopted due to the Tenerife disaster?
Generally, incidents and accidents precipitate changes in rulemaking and standard operating procedures at companies that have, fairly large operations, or even those with small operations. Since Tenerife, the Tenerife disaster, there's been the creation of low visibility operations, surface movement guidance and control system, which describes an adequate example of low visibility taxi plans for any airport which has takeoff or landing operations in less than 1,200 feet runway visual range. And that's further divided into two levels, 1,200 feet down to 500 feet, and then less than 500 feet RVR for those airports that are Cat 3 and B approach capable. Also, runway incursion. A runway incursion is any occurrence in an airport involving the incorrect presence of an aircraft, vehicle, or person on the protected area of the surface designated for the landing and takeoff of the aircraft. And that is an FAA definition. In the year 2000, there was 67 type A and B incursions. And the last hack of the runway incursions was in 2017, and it was 8. So there's been a significant reduction in runway incursions since the year 2000, and that could be given thanks to the advancements in the technology for surface detection and management of the air.
So obviously, these advancements and technology have really helped the aviation industry become safer. But do you ever believe that these systems can mitigate error, but also these pilots are creating reliance on these systems?
The more means by which one has to trap errors through threat and error management, the more likely it will result in safer outcomes. This can be accomplished through automation or SOPs, or a combination of both. Standard operating procedures are fail-safe to automation, visually verifying to ensure what is supposed to be an outcome occurs, and intervening when necessary is a fundamental task of any pilot. Reducing the level of automation is paramount given the level of response needed. For example, a TCAS alert, or traffic collision alert system, when it gives you an RA, or resolution advisory to climb, you can't use the autopilot to respond in a timely fashion. So you reduce the level of automation by turning the autopilot off, so you have immediate control of the aircraft to help prevent a collision. Before having the runway status light system, pilots would have to ensure that it was them or they who received the lineup and wait clearance, or both pilots validating that that was the clearance they received by verbalizing it. This would be a procedure used no matter what, or whether, the RS-LS system was operational or not. So even though you have the automation there, you still resort to SOPs and the old school way of ensuring that you're complying with operational or not. So even though you have the automation there, you still resort to SOPs and the old school way of ensuring that you're complying with the current clearance given by the controller. So the key to preventing error as a result of reliance on automation is to maintain proficiency in your aircraft operations at all levels of automation, and on occasion, Imagine an emergency scenario and think how you would work through it. This helps keep you sharp and allows you to see possible shortcomings in your contingency planning and execution.
Chris, thank you very much. I want to thank you for your time, and I appreciate your input.